Alright, welcome to part one of the weather and climate unit, where we're going to be talking about the atmosphere, the difference between weather and climate, weather instruments, and air pressure. As always, if you need more time, hit the pause button so that you can get your notes. So we're going to be starting with the atmosphere. The atmosphere is this thin layer that surrounds the Earth. It's a layer of gases composed mainly of nitrogen and oxygen. It comes from the Greek word for atmos and sephira, which means a ball of vapor. And it's so thin, it's like if you breathe, onto an apple and the condensation on it, the fog that's on it, that's the same thickness as our atmosphere. So because it's so thin, it's very vulnerable to change. So the atmosphere is important for a couple of reasons. One, it keeps us warm as part of the greenhouse effect. It also provides oxygen for us to breathe, and this makes cellular respiration possible. So not just you breathing in and out, but the actual chemical reaction inside your cells. It protects us from small meteors. It has an ozone layer that protects us from UV radiation, so that we don't get cancer all the time. And it allows the currents to circulate, which is what causes weather. Without the ability for these air currents to circulate, we wouldn't have weather. So the atmosphere is made of a couple of things. The two main things are nitrogen, so it's 78% nitrogen, and oxygen. 21% of our atmosphere is oxygen. And then all of these other gases, argon and carbon dioxide being the two largest, make up 1%. So our atmosphere has a couple of different layers. The first layer is the troposphere. This is where weather happens. This is where we live, so this is where life happens. And this is where most air traffic happens. So most air traffic happens in this layer. Occasionally a plane will have to go into the stratosphere, like to get around a storm, but most planes don't fly in the stratosphere all the time. The stratosphere is the next layer, so the troposphere is the layer closest to the ground, and now we're working our way out. The stratosphere is where we find the ozone layer. The mesosphere is where the meteors burn up. So to help you remember that, the meso and meteor start with the same letters. The thermosphere is where the space shuttle orbits, and it's also where you can find the aurora borealis, also known as the northern lights. So this is an example of the aurora borealis. And the last layer is the exosphere. This is where we merge with space. This is where we can find satellites, and it's where they have to travel in order to get to the moon. So on your notes, you have a picture that shows you the layers of the atmosphere. And these layers are determined by temperature differences. And at the very bottom, or at the side of your notes, where you have a picture that looks similar to this, we're going to draw in a line to give you an idea of what happens to the temperatures as you go up in the atmosphere. So if you start at the bottom in the troposphere and you move up, the temperature is going to get colder as you go up. And the reason why this happens is because there's less air particles, so we get colder. Once we get closer to the ozone layer and then go past it, we're going to get warmer. And we get warmer here because the sun's radiation is not being blocked out. As we continue to go up, we're going to get cold again because we're getting closer to space. There's fewer air molecules, and then as we get to the very top, into the exosphere, it's going to be very hot. And that's because you're in space, and the sun is hitting you. There's no protection between you and the sun. So, on the right side of your paper, if you didn't do this at the same time as me, go ahead and draw this in. So we just talked about the Y. And you also have it on your notes there, so I'm going to kind of skip through it there. Alright, so weather is the temperature, moisture, wind, and air pressure at a given time and place. So weather is what we're actually seeing day to day. It's what your forecast is. You know, it's what is helping you decide what you're going to wear that particular day. Now, this is not the same thing as climate. Climate is the average weather. So, for example, right now, we are in spring, or starting spring. We're coming towards the end of winter right now. So this is the average weather of a particular part of the world at different times of the year. So, like in the desert, the climate there is hot and dry over many decades. It's not just one particular day. So, hot and dry. It's 99% of the time, it's desert. But occasionally, after a rainy period, there'll be some flowers. But the climate of the desert is still hot and dry. So if we think about the perfect outdoor wedding, you know, what we'd like to see is a nice sunny time. So sometimes it doesn't happen that way. So weather is what you get, climate is what you expect. So weather instruments is our next area of focus. So remember, weather happens at a local, regional, and also a global scale. And something like this hurricane, we use different weather stations to get information about what's going on so that we can make weather predictions. There are also weather stations at sea. So the most common weather tools, the first one is a thermometer. The thermometer measures temperature. This is probably the one that you are the most familiar with. Most people have had some kind of experience with a thermometer at one point in their life, most often when you're sick. The next one is a wind vane. So a wind vane measures wind direction. Sometimes you see them, you know, like this, like on the top of a barn. Other times, you know, they don't have a chicken on top of them. They look more like this. This is an electronic wind vane. The next one is an anemometer. So an anemometer, in addition to just being a fun word to say, also measures wind speed. So it doesn't tell you the direction, just the speed. The next one is a barometer. So a barometer is what measures air pressure. And the one that you are more likely to see is the one here on the left that has the numbers on it. The one on the right is a drawing of an older style barometer that you don't really see used that much anymore because it has mercury in it, and mercury's poisonous, so we really don't use that much. The next one is a rain gauge. So rain gauges measure rainfall, and if you're going to be an official you know, weather station at your house, like, you know, when you see on the news, you'll see like the temperature of particular people's houses. You have to have an official National Weather Service rain gauge in order to report the weather. And the last one is a sling psychrometer. And the reason why it's called a sling psychrometer is because you sling it around, and it's a device that measures humidity. So as you're slinging it, as you swing it around, it picks up, it sucks in air, and then the water vapor that is in the air will condense in the tube, and that tells you what the humidity level is. Alright, so our last thing we're going to talk about today is air pressure, or the factor that controls weather. So as you increase in elevation, air pressure decreases. As you decrease in elevation, air pressure increases. So it's a reverse relationship. And in the box over on the side, go ahead and draw these arrows here. to help you remember that as you increase in elevation, air pressure decreases. So again, as you increase in elevation, air pressure decreases. So at the top of this mountain, we have a low pressure compared to the bottom of the mountain, which will have high pressure. And we can also see this in the ocean. As you go down in the ocean, the water pressure gets higher and higher. That's why we need things like submarines in order to go to the bottom of the ocean. So if we were to take this word bank and group these things together, we would have like the Titanic wreck at the very bottom of high pressure. The bottom of a pool would be, kind of closer to the middle. Sea level, zero elevation is right in the middle. And then low pressure would be like a hot air balloon, and then the top of Mount Everest. And a jet plane would be even higher than the top of Mount Everest. So at normal atmospheric pressure, at 1 atm or 1 atmosphere, the boiling point of water is 100 degrees Celsius or 212 degrees Fahrenheit. So I wrote 212 in there. High pressure generally means good weather. So when you see, a nice blue sky, a nice puffy white cumulus clouds like these are, it's a high pressure system. Low pressure means poor weather is coming. So when we see a low pressure system move in, and you probably all have seen a storm front move in at some point, you can actually see it moving in that way. So air pressure drives the wind and creates the weather. And as warm air rises and cool air sinks, we need to remember that warm is low pressure and cold is high pressure. And you may want to add that in the box where you drew the arrows, that warm is low pressure and cold is high pressure. So this is the 3 ways that heat can travel. The first way is convection. Convection is a circulation. So we talked about convection currents when we were talking about plate tectonics, because that was how magma moved through the earth, was through convection currents. The second way is conduction. This is the movement of heat from one molecule to another. And the last way is radiation. So go ahead and label your pictures. I'll actually go back so you can see the pictures again. Go ahead and add the words in so that you are clear about what each one looks like. Alright, so using a frying pan and oil to cook popcorn is a good example of conduction. A hot air popcorn popper is convection, and a microwave is radiation. And to sum it all up for today, I got a little rap song for you. Oh, maybe I don't have a little rap song. There we go.
There are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. First things first, let's discuss heat, what it is before you pay for it to warm your feet. Heat is the energy that flows when atoms and molecules move. It diffuses out towards coolness. Temperature is the measurement of the average motion of these atoms and molecules in the atmosphere. So there you have it. Now the first way of transportation of heat energy is radiation, like sound waves from your radio stations filling the empty space around you. Your radiator warms you, but don't start a fire now, I warned you. Heat is going through radiation the sun before it burns you. From 93 million miles away, to re-radiate this heat is what the earth does for you. This is survival, what this heat is going through before it rises to the sky and it's gone. So there are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Conduction, the second method on my list. You can feel it like a hot pot in your fist with the handle gripped. I bet you'd rather grab a candle lit, cause it's heat through conduction that causes this. Atoms and matter in a fixed position vibrate when heated like a pan in the kitchen. Transmit the heat energy to atoms next to them that are cooler than they are, to cause equilibrium. To even out the temperature, the heat has to travel up the spoon in your tea in the morning with your bagel. It might burn your hand, but just learn the land of conduction, heat energy, until you understand. The earth gains little from conduction. It's mostly radiation that helps us function and keeps us warm. It's just another way for heat to move. But now let's move on to method 3 to prove. There are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Convection is the movement of heat in liquids and gases to even out the temperature fastest. This process is called diffusion. It's a flow of particles cold and hot in a fluid. If you're not listening, then stop what you're doing, cause this is the final mode that heat can move in. And this affects you every day. It's the breeze at your back and the wind at your face. When heat reaches the earth, it rises at a rate with the air in the place, and it moves up till it cools. Trillions of molecules together make up the weather that we see on the news. It's how they measure the pressure of the air and the temperature, but convection is how it got there in the atmosphere. So don't be scared. Heat moves in 3 ways, so we made things clear. It's like there are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are 3 ways that heat can travel, but it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection.
Alright, so if you did what you were supposed to do and actually watched the entire thing, including this rap, come and let me know and I'll give you a piece of candy.